The scatter plots are one of the most important graphs and plots in statistics. Scatter plots allow us to see the relationship between two variables. In Stata, the command to run those is two-way scatter. And then here you can, normally you put the variable that you want on the y-axis first, and then the variable that you want on the x-axis second. So I'm going to just run this and show you this. So this is a basic scatter plot between the variables, because basically GDP per capita doesn't change much on time, but it changes across countries. That's why we have this this distribution. You can see that there is, as GDP per capita increases, it looks like the daily or the number of cases tend to go down. So these dots means there's a intersection between this GDP and cases, but these dots also mean that there might be dots on top of each other. So that's why we have this sort of like it looks more like a bar graphs, right? So to address that, we're gonna run the same graph, but with some options. So you put a comma there, and then there's common option. The option that one of the options that Scatter has is jitter. What jitter does is that it kind of like it gives some random position to the dots. So it's gonna separate the dots that are on top of each other a little bit, dancing around each other, so we can see the trends better. And now notice, now we have, instead of T label that we use in the time series, now we're going to use X label, because GDP per capita is not a time variable. And the format is pretty much the same. It goes from 0 to, previously I checked the summary, I did a summary of GDP per capita, and then I noticed that the highest value is under 1,000, 100,000, 112,000 dollars. So basically I'm going to put this one as the max, and I want the separation on the x-axis by 5,000. After the comma, it comes with how you want to see the labels. I want to make it smaller in 45-degree angle. Also, I want this, remember this is to add a comma to the thousands, and I want a grid. The Y label, I want to keep it as is, but in this case I also wanted to have it at 45-degree angle with a comma in the thousands. So I'm going to just select this and run. You notice the graph now, because the dots were moved around a little bit. Now we have a sort of like a better view of the distribution of it. We have a big gap in here, in around 100,000. But it looks like we have very few cases in the poor population towards the lower levels of income, of GDP per capita, having higher cases on average, so 7-day moving average, and it looks like there is a downward trend. So let's verify that with a second graph, which is a graph that provides some sort of like a linear fit. Now, one of the things that you need to notice here is that this is not exactly a linear fit. So what we're going to do is we are going to impose a little bit of a linear fit to this. So this is just to show you how to add a trend line into the graph. So the graph is pretty much the same as before, but remember we're gonna add a new graph. So we need to put the two parallel lines with the 3 forward slashes, and then the command for the graph for the trend line is lfit. So it's basically linear fit. And you have to put the two variables in the same order. And I'm going to change the color to the line. I want it to be white because there is a dark blue in there. So I'm going to select this. So and you can see here in the Y line, this is how you add a trend line into the scatter plot. It looks like even though we have this huge, a few cases here, those cases might not be as strong or as relevant in order to influence the trend. So it looks like the trend is going up based on the data. So what this means is that according to this, as higher levels of income generate higher number of cases. So that's pretty much what it is. Let's see the same graph, and instead of cases, let's use deaths. And here we have a similar trend. Even though we have this huge amount of cases here, the trend seems to be positive as income, GDP per capita increases. So let's play around with the markers. In this case, if you notice here, I'm not going to add any symbols because we have like a full circle for the scatter plot. Instead, I want to replace that with the labels. So you can add the dots and the labels, but in this case, it's going to get too crowded in there. So I'm just going to remove the markers, but I want the labels based on the country, preferable smaller, and center instead of basically center in around the dot. And the rest is the line fit. So I'm just going to select that and run. And what this does, instead of seeing the dots that we see before, we can see the name of the countries. Mostly because I'm interested in seeing the outliers or the possible outliers on each of the categories. So here on the poor side, we can see that the countries are Grenada, Chile, Ecuador, etc. As we go into the richer, we see in between 75,000 and 80,000, Norway, Ireland, Luxembourg. Those are the countries with higher cases. Between 35 and 40,000, we have Andorra, the Bahamas between 25,000 and 30,000. So here you can see the strengths. Still we have the linear fit, and then you can start making your own inferences. So those are the graphics. So the scatter plots allow you to see, in some cases, the trends are way too linear or way not. But you need to keep in mind that we are just looking for patterns, right? We want to see whether what kind of relationship is between those two variables. If you want to have some sort of like a numeric version of that relationship, then we need to actually start getting what is called the correlation. So, but before we get to that, we are going to look at one more variable, which is the trust in government, because so far we plot the cases and that's against the GDP per capita, which is one of the questions that we are testing here, whether richer countries how they deal with COVID. But now let's see if we can use the trust variable. So the trust variable is the confidence comes from the confidence in government, and let's plot that with the daily deaths. It's pretty much the same format as the one we've been using. So let's see how that looks like. So this looks like a little different. So if you notice on the x-axis we have levels of confidence, it goes from 0% to 100%. On the y-axis, we have the 7-day moving average of deaths per 100,000. And the linear, even though we have a few outliers here, the linear trend that we are estimated, it goes down. Basically, what this says is, or it suggests, is that as people have higher levels of confidence in their governments, the number of deaths per 100,000 tend to go down. So this contrasts with the positive trend that we saw in the case of the GDP per capita. So the correlation gives us an idea of the possible relationship between two variables. If you want to have some sort of like a metric of that relationship, then you need to estimate what is called a Pearson correlation coefficient. And to do that in Stata, the command is pwcore. There is also another command called core. I really like the pwcore because it provides some sort of significance of the relationship. So the command starts with pwcore, and then here you can list all the variables that you want to check for correlation. And then as an option, we want to add, we want Stata to tell us, so to mark with a little star those who were significant. And we want the significant levels too. So I'm going to select this and run. And for this one, you have to go to the main Stata, and this is a correlation matrix. Each one of these coefficients is a Pearson correlation coefficient, which is basically a correlation between the two variables. And correlation coefficient goes from -1 to 1, closer to the ones on either side means stronger correlation, closer to 0 is weaker correlation. So in this case, we have the dailies. The first one is the cases versus with the deaths. There is a 0.3 correlation. You might say that this is basically on the lower end, lower moderate correlation. The cases with GDP per capita is positive and significant, is 0.23. The daily 7 deaths with GDP per capita is positive but very slow, 0.09, so it's kind of on the low side. The daily 7 cases with trust confidence in government is actually negative, but very, very small, 0.06, and significant. In the case of deaths, it's actually higher. It's negative, which is basically is 0.24. Basically what it says, one additional value of one additional percentage. And as trust increases, the daily number of cases goes down, and the level of deaths also go down. In the case of GDP per capita, it seems that the cases go up. And that gives us a little bit of a better understanding of these relationships. Now, one thing that you need to keep in mind is that correlations refers only to linear regression. So we are assuming that there is a linear fit in these variables. It could not be that the case. It could be non-linear, but this just gives you a general idea of what the relationship is between those two.